So we'll be doing some HackerRank problems today, which is based on list. Okay. So go to hackerrank.com. Okay, hackerrank.com. I hope that you have already made an account in the hackerrank.com. How to make an account? It's very simple. You open HackerRank and you sign up with Google or Facebook. How you open Twitter account, same like that only. How you open Facebook account, same like that. Here also you can open. There is no much difficulty in it. Once you open HackerRank account, okay, go below and go for data structures. Okay, click this data structures, skills available for practice. In that section, go there. Now what you can do is you can go little below and you can click here linked list. You can click this linked list and you will get the linked list questions. Okay, so the easy question which we will do is insert a node at the tail of linked list. Let's do this. Right, insert a node at the tail of linked list. So we'll click this now. Okay, so let's read the question. You are given a pointer to the head node, right? Yes, they will give us pointer to the head node. For example, what they are trying to tell is they are telling that there will be a node like this. Okay, that is node 10. Okay, and the next node is 20, but this address is 2222. That is stored here, which means this connection is there. This node address is 1111. It is stored somewhere here, which means this is connecting here, and this variable is what? First, right? First node, or you can tell it as head node. This is called as head node. Where is head node? So they will give us this node. Because I have 111, I know where to connect, and because in the 111 object there is a 222, I know where to connect, and so on. Okay, so what they will give is they will give this address. They will give 111. They will tell the address of the first node. They will tell. Okay, that's what they are telling. Now let's see. Then what you have to do, right? Okay, so you are given a pointer to the head node of a linked list and an integer to add to the list. So what integer you have to add, that is also given. Okay, so create a new node with the given integer. So whatever integer they give, maybe 10, I have to tell new node of 10, so that a new node is created. Insert this node at the tail of the linked list. Okay, we have to insert this node at the tail of the linked list and return the head node. Okay, return the head node of the linked list formed after inserting this new node. Okay, that is what they're telling. They're telling that they will give a number 10. Okay, maybe number 50. Using that 50, you have to create a new node. Okay, and they're telling that connect this here in the tail of the linked list. Connected. Okay, we have connected. After connecting, they are telling that return the head node. Head node is 111 only. Yes, you have to return 111 again. Why? Because when you return 111, it will travel here and it will print all the numbers, and now it has to print 50 because you have inserted 50. Yes. So what is your task? Create a node, connect it. After connecting, return the head node, because when you return the head node 111, the program will again travel from 111, 222 and all, and finally it has to print 50. Okay, so it will print 50. You don't have to worry. You just have to insert a node at the end tail of the linked list. That's it. Okay, so insert this node at the tail of the linked list and return the head node of the linked list formed after inserting this new node. The given head pointer may be null, meaning that the initial list is empty. Yes or no? Yes. Imagine if there is no node at all. If there is two nodes, you know how to add at the end. Yes or no? But what if your initial head is empty? If it is null, what if the head is not pointing to anything? In that case, the new node is the first node only. Yes. Okay. Input format. Okay, we'll not worry about that. Why? Because okay, here you can see this is our code. Okay, can you see the different color here? I'll expand so that I'll get to know okay what is the code here. Okay, so singly linked list node, okay, is a class. In that class there is a data type and there is a next type. Next is of what type? Yes sir. Next is of, yes, class type. Okay, see in my example, this, whatever you are seeing here, okay, whatever you are seeing here, don't you think this was written as NODE? Yes, it was written as NODE, but now it is written as singly linked list node. Okay, so that changes we have to do, that's it. So if I come here, see here if I had class node, then your next type data was node type. Yes, this is same as the class name only, same thing like that. Here also the next is of same type of class name. Okay, you have a constructor, right? Whenever you get data, right, that data should be given to the class data, and next is null by default. Okay, so this is the normal which you have done also, right? Okay, then let's see what else is there in this. That's it. Okay, so we have to create a new node. Let's see. So this is for a reference, it seems. Okay, this is for a reference. Okay, I'll delete this, no need for the reference now. Okay, so we have to complete this method. Okay, we have to complete this method. So this method, what's the method name here? Method name is insert node at tail. Method name is what? Insert node at tail. This method returns what type data? This method returns singly linked list node type data. It returns singly linked list node type data, which means you have to return the head. Okay. Okay. So now what we'll get is, this method is receiving two information. This method is receiving what information? Two information. Okay, the first information is the head node, and the second information is the data, what data you have to add. Okay, now what I'll do is like this. First of all, I'll create a new node. Okay, sorry, node new, right, is equals to new node of what? Of data, right? Whatever data they have given, that's a new node I have to create. But should I tell node here? No, I should not tell node, because node was my class. For them, the class name is like this, singly list node, and here also I'll be telling the same thing. Okay, so new node is created, right? So now what happened is, let's imagine, right, our head was pointing like this. Okay, so let's imagine we had a head here which was containing 1000, and it was pointing to the first node 1000, and this was containing the data 30. Yes, and it was there was one more node which was 2000. The 2000 is stored here, which means this connection is there here, and it was storing 50. Okay, so this was the case, and it was pointing to null. This is the case now. Now let's do one thing. Let's put the first test case. What's the first test case? It is, what if the head is null? Yes or no? What if the head is null? If head is null, it means that it is not pointing to anything. Yes or no? It is not pointing to anything. If it is not pointing to anything, then I have to create a new node, right? I have to create a new node, and I have to add the data. The new data is 70, and it is null. It will have an address, right? 3000. This 3000 I have to give it to whom? Head. I have to store it in head. That's it. So create a new node, directly give it to head if the head is null. So this is the basic condition, right? Or let's say the basic condition, that is, if head is equal to null, means there is no object, there is no node in the list. This is the first node which you are adding. So directly give it to the head, I have to tell. So what I have to tell here? Okay, after creating new node, I have to check one condition. If, right, if my head is it equal to null. Because if head is equal to null, then, okay, whatever new node you have created, okay, here let me write like this, whatever new node you have created, right, just now, where is it present? Okay, the new node. Don't you think this line has created a new linked list node that is stored in NEW? The address is stored where? NEW. Whatever is stored in NEW address, you give it to whom? Head. You give it to head. That's what I have to tell. Okay, so what happened now is, now Okay, I am creating a new object like this with the address 3000. I am storing it in a new address, okay, new variable. So 3000 is stored. It means 3000 is pointing to this object. After 3000, no, after new is pointing to this object, now I'll check whether my head is it empty or is it containing something. That's why if my head is empty, right, if my head is null, then 3000 should come here. So that head is pointing to this. So from the new, give it to the head, I have to tell. So that's what I have told. From the new, give it to the head, right? But for this, if there is one else part, right? Else part is what if head is not equal to null. Okay, if head is not equal to null, then let's see what to happen. But you should understand that whatever might happen at the end of this if and else, this is the closure of this method. Before the closure of this method, we have to return the head. We have to return the head. That is our task. After inserting, return your head, they have told. Okay, now I am returning what? What type data? I am returning head, which is a linked list node type data. And we know that the return type is that only. Can you see the return type is linked list node? Yes. So return type is that. So here, now it means that head is not null, which means I have to add this node at the end of the linked list. Which means let's imagine like this, okay. So now head is pointing to 1000 and 1000 is pointing to 2000. Okay. They have told me to add at the end. They have told me to add at the end and they have called the method. What did the method do? The method created this node and new is pointing to this 3000. Clear? So this is what my method has created. This is what my method has created. Now my task is, what is my task? My task is to add this 3000, okay, to add this 3000 here, so that this connection is there. I have to add this new node to the tail of the linked list. So how do I do that? Here it is null, right? Now how should I know that this is the end of the linked list? Yes or no? Now that's why what I will tell you, no? I will get to know that this is the end of the linked list. So I have to add this node here, okay? So what I will do is I will write a while loop, okay? I will write a while loop. What while loop I will do is I will check like this, while, okay, while, if I am using while loop, okay, I have to use a while loop. And now don't you think I have to traverse here? Yes or no? I have to traverse. I have to traverse to this node, I have to traverse to this node, which means I need a pointer now. I need a pointer. But can I use the head as a pointer? No, don't change your head pointer. Is it clear? Because head should be pointing to the main node, first node. That's why I have to take a temporary pointer, where initially temporary also should point to the head node. Yes or no? That is why I will tell here, okay, while loop is there, but before while loop, I have to create one temporary value, which is same as head node, This temp is of what type? That temp is of linked list node type, okay, single linked list node type. This is what I will tell. So head value, whatever is given to temp. So what is the head value now? I'll write the temp value here, okay. I'll write the temp value, which is same as the head, that is 1000, which means it is also pointing to this. Now I have to check, is this the last node? Yes or no? Is this the last node or not? I have to check. How will I get to know if this is the last node? Okay, if it is pointing to null, it is the last node. That's why I'll check. Is this pointing to null? No. Right? Is this pointing to null? No. Is this pointing to null? Yes. If it is pointing to null, then this is the last node. Agree or not? Yes. That is why what condition I have to check now. Okay. So what I have to check is like this. Okay. When my temp value is 1000, right? 1000 dot next, is it equal to null or not? I have to check. Temp value is 1000. What is 1000 dot next? 2000. Right? Is it equal to null? No. That's why what I have to check is, while I have the temp value, I have to check whether a temp dot next, is it equal to null? I have to check. Okay, is it equal to null or not? Okay, this is what I have to check. Is it equal to null? Tell me, what is the temp value? 1000. Is 1000 dot next? What is 1000 dot next? Here it is stored what? 2000. Right? Is 2000 equal to null? No. Condition is false. Right? Condition is false. That's why I have to tell like this. It should not be equal to null. It should be not equal to null. Yes, 2000 is not equal to null. Correct. If it is not equal to null, then what should we do? Then what I have to do is I have to tell, okay, if 2000 is not equal to null, then temp should increment here. Yes or no? Temp should increment here. And I have told you how to increment temp like that. That is, temp is equals to temp dot next. This will increment the temp. How this is working, I will tell you. Now what should happen? Temp was pointing here. I got to know that 2000 is stored here. If 2000 is stored, means this is not the last node, right? Which means what should happen now? If temp has to point here, don't you think 2000 has to be stored in the temp? Yes. So I'll tell something has to be stored in the temp. What has to be stored? 2000. Where is 2000 present? 2000 present in 1000 dot next. And what is 1000? That is nothing but the temp value. We have already seen this. I have to tell the new temp value is old temp value dot next. And what is the old temp next? 2000. That 2000 has to be given to temp, so that it will contain 2000. And now, as you can see, my temp is pointing to this object, right? My temp is pointing to this object. Now to check whether is this object last node or not. Is this object last node or not? I have to check. And how will I get to know? I have to check. Now temp value is 2000, right? So in this, can you see here 2000? 2000 dot next. What is that? Null. Yes. So according to the code, 2000 dot next. What is 2000 dot next? It is null. So null is not equal to null. Condition is false now. Previously 2000 was not equal to null. Condition was correct. But now, sorry, previous it was 2000 was not equal to null. Condition is correct. But now it is null. Is null not equal to null? No, because now temp dot next. What is temp dot next as of now? The temp dot next is null now, right? The next is null. Is null not equal to null? No, null is equal to null. So the condition is false. When the condition is false, control will come out. Yes or no? When the condition is false, control will come out. And when the control comes out, don't you think I'll have the temporary variable ready pointing to the last element here? Yes. When the control comes out of the while loop, I have this temp variable which is pointing to the last object. Yes or no? So what is there here? Now what is there is, okay, temp, it is containing 2000 address. It is pointing to this. Now what should happen? Understand here. What should happen is this 3000, right? So let me write in the number way here. 3000 has to be stored where? Has to be stored here. Here 3000 has to be stored here. So that this link can happen. Agree? This link can happen. But 3000 has to be stored where? In this location. And how do you get to this location? You will get to this location by telling 2000 dot next. You will get to this location. So 3000 is stored in where? In 2000 dot next. So in 2000 dot next, your 3000 is stored. And in the variable, what is this 3000? 3000 is stored in which variable? 3000 is stored in new variable. That's why I will tell, new value has to be stored in 2000 dot next. Where is 2000 stored? 2000 is stored in temp. So I will tell temp dot next. This is what you have to tell. Temp new has to be stored where? Temp dot next, which means head is connected to this node is connected to this node, and this node is connected to this node. We have added a new node to the tail of the linked list. Okay, so that's why I have to tell now temp dot next is equals to new. Here I have to tell after the while loop is completed, temp dot next equals to new, new variable. Okay, that's it. So I have added, right? After adding it to the tail, but at the end we have to return head because our task is to return the head. That's it. So what is this while loop responsible for? This while loop is responsible to find the last node. Okay, how? It is like this. Imagine you have a node here, right? And address is 1000. Let's say address is 2000. This address is 1000. Right? And this 2000 means what? It is connected to an object address is 2000. Okay, it is connected to an object address is 3000. Okay, 4000. It is connected to an object whose address is 4000. And it is connected to null. Means this is the last object. It is not connected to anything. So what I have to check, when my temp is containing 1000, means temp is pointing to this object. is 1000 dot next part, is it null? It is not equal to null. Yes, if 1000 dot next, if it is not equal to null, then go to the next temp. Temp will increment here. Okay, so what is the temp value now? 2000. So is 2000 dot next, what is 2000 dot next? 3000. It is not equal to null. Yes, whenever temp dot next, if it is not equal to null, update your temp. Yes, temp dot next is 3000, which is not equal to null. So update your temp here, 3000. Temp will become 3000. So what is 3000 dot next? 4000, which is not equal to null. Update your temp. Update your temp. What is 4000 dot next? It is equal to null. Don't update your temp. Let your temp be here. So we have to stop, right? So we have to keep on going further. If temp dot next is not equal to null, go to the next, right? So when the condition is false, control will come out. But when the control comes out, don't you think temp is pointing to the last node? Yes. So that is why while loop is responsible. Now our task is done. Let's run the code. Let's see. So sample test cases passed. Submit the code. So all test cases passed here. Okay, all test cases passed. So how do you go to the linked list question? So go to the HackerRank. This is the main page of HackerRank. And when you go to the HackerRank, go below, and there you can see data structures. Click data structures and click linked list here, right? And insert a node at the tail of linked list. We have done that, right? Okay. Print the elements of a linked list. Okay, this is also easy. Let's see. So we'll come here, right? Yes, we will delete the reference. We don't need the reference. If you want, we can see the code, right? But understand one thing, this yellow, whatever you're seeing, in the orange color, light pink color, here I can't write anything. I can't write anything. Like, it is locked code, which means you can't modify the node class if you wanted to. Okay, but understand, this class, it accepts one data and it will point to where the next node should point. There is a constructor. Okay, normally whatever I have written. Okay, let's see. So they will give us one head. If they give us one head, what we have to do? We have to print all the elements. Okay, it is like this. Okay, what they will do is, as in this picture, they will give the head 1000. You have to print all the nodes connected to that head. Okay, that's it. So simple. Its return type is what? Void. So what we will do is like this. As I told you, if you want to traverse the node, create a temporary node. Okay, let's create a temporary node. So singly linked list node type temp is equals to whatever head is pointing, wherever head is pointing, that address, the first starting address, give it to temp. Once temp has a starting address, okay, I'll use a while loop. Okay, I'll use a while loop. And in the while loop, I will tell like this. Okay, watch here. Let me take an example. Okay, so understand here. Okay, so head is pointing to this 1000 object. If this has to connect like this, its address 2000 has to store here, so that this object knows where should I go next. 2000 you have to go next. Okay, so 3000 means it is connected here. 4000 means this object is connected to 4000. Null means it is not, this the last object is not connected to anything. Okay, so now first what I have to do is I have to traverse through this string. I have to traverse. If I want to travel, I need a pointer. If I want a pointer, I have to create a new pointer. I can't use the head pointer. It is wrong. The practice is wrong. The head should be always pointing to the first node. So I have to create a new variable called as temp, where temp should be pointing to the the head value should be given to temp value, which means temp is also pointing to this node. Now if temp is pointing to this, how do I print 10? If I want to print 10, that is temp.data. So I will tell what here, while one condition is true, okay, system.out.println, okay, I want to print what? I want to print temp. Okay, I want to print temp.data. This is what I will tell. Okay, I want to print temp.data. But before printing this temp.data, make sure that temp is not null. Only if temp is pointing to an object, you can print its data. Agree or not? If temp is pointing to a node, the node you can print the data of the node. Node's data you can print. But what if, right? What if your temp is pointing to null? If your temp is pointing to null, it means that temp is not pointing to anything. If temp is not pointing to anything, where is the data question now? Yes or no? There is no data, right? That's why you have to print data. Okay, you have to print data. You have to print temp.data provided, right? Provided temp is not equal to null. Okay, if temp is not equal to null, then only print temp's data. Now, initially we know our temp is 100. 1000 is not equal to null, so print 1000.data. 1000.data is 10. After this is printed, don't you think my temp has to increment? Yes. If temp has to increment, okay, in this location what should come? 2000 should come, right? Which means 2000 should be stored where? In the temp I have to tell. Okay, 2000 should be stored in the temp. But right now, where is 2000 stored? 2000 is stored. 2000 is stored. Where is 2000 stored? In 1000.next. So in 1000.next, your 2000 is stored. What is 1000? 1000 is nothing but your temp. Don't you think your temp value is 1000? So right, like this. So this is how to update your temp from 1000 to 2000, which means now temp will be pointing to this object. So this is what I have to tell, that as soon as you print temp.data, right, you increment your temp. So temp is equals to temp.next. This is what you have to tell. That's it. Now what happens? Temp will increment. As soon as temp moves, first it will check, hey, temp, is it not equal to null? Yes, temp value is 2000. 2000 is not equal to null. Then print 20 and temp will become 3000. Right? So this, what is this temp.next? This temp.next is 3000. That is the new value. Okay. So after temp becomes 3000, your temp will point to this now. Okay, is temp, is it null? No, temp is not equal to null. If temp is not equal to null, means it is pointing to an object. Print the data of that. 30 it will print. As soon as it prints 30, it will tell the new temp is old temp. What is 3000.next? 4000. 4000 will come here, which means temp is pointing to what? 4000. Is temp equal to null? No, temp is not equal to null. Whenever temp is not equal to null, means temp is pointing to an object. Print the data of that object, that is 40. It will print 40. As soon as it prints 40, okay, you are telling, let me trace it here. Okay, right now, what is the temp value? Temp value in the memory is 4000. What is 4000.next? Can you see in the 4000 the next part is null? That null, don't think you are storing in temp? Yes, your temp value becomes what? Null. Okay, means after this there is no next object at all. There is null, there is nothing. Okay, what's the temp value? Null, right? And if the temp value is null, when you check the while loop, okay, null, temp value is null now. Null not equal to null, condition is false. Null is equal to null, but here we are asking null is not equal to null, so condition is false. If the condition is false, will it print temp.data? No, because now temp value is null. What is null.data? There is no null.data. That's why there is a problem. Okay, but we are escaping from that problem. So we are printing only the temp.data if temp is not equal to null. So I hope you have understood this problem. We have already done this, right? So now I'll run the code. We don't have to return anything because here, can you see the return type is void? Yes, you don't have to return anything. Sample test case passed and all the other test cases also will pass. Okay. So as you can see, these are the simple ones, right? Simple programs. This is all which they will ask in the interview. Okay, create, add a node to the end of the list, add a node to the beginning of a list, right? So again, we will go to data structures, linked list. Yesterday only we have done insert a node to the head. That I'll give you as homework. You try it on your own. Deleting a node also we have done. Remember, deleting means what? Connection should be there from, if you have to delete 2. See, 1 is connected to 2, 2 is connected to 3. You want to delete 2, which means connection should be maintained from 1 to 3. That's it. So print in reverse, we can do it in many ways. We can show it in stack, then we can print the stack one by one. That is also fine. Okay. So all these things you can try. Okay, all these things you can try. So this is the thing for today's class. Okay. So in tomorrow's class, I'll be starting with the merge sort. Okay, I'll be starting with merge sort, but directly I won't explain merge sort. Before that, there are some things which you have to understand about arrays. So we will do that. But now, okay, only 30 minutes of the class is over. What I'll be doing is, I'll be cutting this video, I'll be stopping this video, I'll make a new video which you'll be seeing today itself. That is how to apply for Google. And once you get the invitation, how do you attend the question, because it is very confusing in the beginning. Okay, there is a lot of story and all. What you have to do, how to compile, how to execute in the Google console, everything I'll tell you. So watch the next video which is there in the YouTube playlist now. Okay, thank you for watching this video.